Hello, this is question 4 on June-November 2021, paper 3 from AQA, and is a binomial expansion with an integer or a natural number as an exponent, which is what you see in year 12, but it's a year 13 question. So you have to show that the first three terms in descending powers of x of the expansion, this one, are given by this expression. And p and q are integers that we need to find. Yeah, so let's going to expand that. Remember, you have the formula in the formula booklet. So we have 2x minus 3 to the power of 10. So the formula is here in your formula booklet. Yeah, you have the binomial expansion when n is a natural number, which is the case in this question. So we do the first one to the power of 10, then plus 10 chooses 1, the first one again to the power of 1 less, and then the second one together with the sign to the power of 1, and we need the first three terms. So we have 1, 2, and one more, and then plus 10 chooses 2, 2x to the power of 1 less, so 8, and minus 3 to the power of 1 more. Yeah, and we don't need more, but what we are going to do is to simplify the exponents. So we have 2 to the power of 10, which is 1024, x to the power of 10. Then, with the calculator, you can do always this with this thing here. So you have a key in the calculator that says 10 NCR. So your n is 10 and your r is 1. And you do this with the calculator. You multiply by 2 to the power of 9 and multiply by minus 3, yeah, to find the coefficient. I will do that all straight away with the calculator, and this is a big number. All to the power x to the power of 9. And again, with the calculator, you do 10 chooses 2, so 10c2, multiply by 2 to the power of 8 and multiply by minus 3 squared. Or you can just multiply by 3 squared and just you can think the same sign yourself. And this is, again, a big number. 0x to the power of 8. Yeah, so we have the first three terms in descending powers of x. And p and q are constant to be found, so I will just make a note that p is minus this number here and q is this number here. Yeah, every time they ask you for constants, even if you write the expression, I will write the value of the constants apart just in case. And then find the constant term in the expansion of this. Constant term is the term that has no x. So if we expand this, what is going to happen is I have x's in the numerator and x's in the denominator. Yeah, so let me show you, we can expand a few. So if we expand that expression, because you will need to think a tiny bit. So you have 2x to the power of 10 plus 10 over 1, or 10 chooses 1, 2x to the power of 1 less, and the second term together with the sign and the coefficient to the power of 1, and so on. So what happened is that I have x's in the numerator and x's in the denominator, so they are going to cancel. If I want the constant term, if I want the term without x, I will need the same number of x in the numerator than in the denominator. So I need the same exponent here and here. Remember, these numbers in the exponents always add up to my exponent. So I will have to have 5 and 5, so they add up to 10, and the 5 cancel with the 5. Yeah, so that's the term I'm looking for. I'm looking for the one that has a 5. So I will have more terms here that I'm not interested in. I will have something here, and then I will have 2x to the power of 5 and minus 3 divided by x to the power of 5. So this x to the power of 5 cancel with this x to the power of 5. And here I'm going to have always 10, and in this case 5, yeah, which is this exponent. But in this case it is the same in both of them, but it's always the second exponent, yeah? So 10 over 1 in this case. And if you don't remember well, you can have a look to the formula. So in the formula you see that the number here is the exponent of the second term, yeah? And it's just finding the number with the calculator. So you do 10 chooses 5, multiply by 2 to the power of 5, multiply by 3 to minus 3 to the power of 5. And that coefficient that we are looking for is minus this very, very large number. Yeah? Yeah. So that's all with this question.